let's do some examples for radius and interval convergence. So we have x to the n over 2 to the n. And we're going from n equals 0 to infinity. So when we do this, what we want to do is we want to use the ratio test to take it all the way out to infinity and find essentially values that allow that limit to be less than or equal to 1. And I can say that in words, but it's probably a lot easier just to show you. So what I do is I say, okay, this u sub n is x to the n over 2 to the n. So u sub n plus 1 is x to the n plus 1 over 2 to the n plus 1. So I guess what I probably should have done before that is figured out what the center of this power series is. Well, what I do here is I say, okay, what value do I plug in for x that would eliminate all the terms except for the first one? Well, if I plug in 0 here, it's going to, 0 to whatever power is just going to be 0. So that tells me that my center is 0. Okay, now when I do this, I say, all right, I need to take the limit as n goes to infinity of the ratio of the next term to the current term. Well, that's the limit as n goes to infinity of x to the n plus 1 divided by 2 to the n plus 1 divided by x to the n 2 to the n. Now I'm going to rewrite that as multiplying by the reciprocal to get x to the n plus 1, 2 to the n plus 1 times 2 to the n x to the n. I'm going to rewrite that one more time. It's x times x to the n, 2 times 2 to the n times 2 to the n for x to the n. So I do that obviously so that you can see cancellation pretty simply. Now we have the limit as n goes to infinity of x over 2, which is just x over 2. Now, here's the thing. For a geometric series, or for really not even geometric series, but for the ratio test to show convergence, that limit has to be less than 1. So this thing converges if that limit is less than 1. So I have to say, all right, if x over 2 is less than 1, I know the limit converges. Which means that x, the absolute value of x, is less than 2. So since the absolute value of x is less than 2, that tells me that I could go all the way to -2 and all the way to +2, but these are parentheses, they can't be brackets because this isn't less than or equal to. So this is my interval of convergence, and my radius of convergence is 2. So that's going to be your radius of convergence right there, by the way. And your interval of convergence is going to be based upon your center. In general, what you're going to have is something like this. You're going to have your center minus your radius, your center plus your radius. So in this case, your center was 0, and your radius was 2. So 0 minus 2, 0 plus 2. And that's your interval of convergence. Simple enough, right? So we're going to do the same thing. But now instead of x to the n over 2 to the n, we have x minus 3 to the n over 2 to the n. And what we're going to see is this is almost exactly the same. So my center is actually 3, because what I realize if I plug in 3, that would zero out every term except for the first one. And then I'd say, all right, my u sub n is x minus 3 to the n, or 2 to the n. I get that. So then when I take the limit here, I'm going to say, all right, the limit as n goes to infinity of x minus 3 to the n plus 1, 2 to the n plus 1, divided by x minus 3 to the n, or 2 to the n. Now I'm going to skip a step here. I'm going to say, or actually I'm going to combine multiple steps. So I'm going to split this out as x minus 3 to the n, and 2 to the n. And then I'm going to take the reciprocal and multiply 2 to the n, x minus 3 to the n. So we can clearly see that we're going to have cancellation there, which gets us the limit as n goes to infinity of x minus 3 over 2. Now this limit is a limit in n, but there are no n's here, so this is treated as a constant as far as the limit is concerned. So I have x minus 3 over 2. Now I can also do that because the absolute value splits over top and bottom, and the absolute value of 2 is just 2. So what I know is that if I can show that this limit is less than 1, then it converges. If I can show that limit is less than 1, it converges. So then I rewrite that as x minus 3 is less than 2. So what this tells me here is that the radius is still 2. But the center is now 3. So we have to use this form, the c plus r, c minus r. So again, c is 3. So I have 3 minus 2, 3 plus 2. So my interval is from 1 to 5. So that's my radius, and that's my interval of convergence. Again, just using this formula. That's one of the easier ones to use. Now, finally I have x to the 2k over 2k factorial. So to do this problem, we're going to do it just like we did all the other ones, but we now have a factorial, so it can complicate things a little bit. This marker looks terrible. I'm going to get a new one. So the first thing you'll notice is instead of using un, I need to use uk. The reason being is that this is indexed on k, these were indexed on n, so it's important to be consistent here. So this is now 2k plus 1. So notice that I didn't just add 1, I didn't write 2k plus 1. I did 2 times k plus 1. So be careful, that's a very common mistake that happens. You just add 1 here, but you're really replacing k with k plus 1. So you have to do it kind of in parentheses. Over here, it didn't matter because if I replace n with n plus 1 in parentheses, I can just remove the parentheses. But over here, I'm going to end up multiplying by 2, so I have to be careful. Also notice that my center is 0 because if I plug in 0 for x, everything disappears except for the first term. So I'll take the limit. Again, this is as k goes to infinity here. So I'm going to rewrite that as 2k plus 2 by distributing that out. And so then what I need to do from here is I'm going to simplify this side and then I'm going to flip that reciprocal. Or I'm going to multiply by the reciprocal. So still thinking in terms of n. I got to think in terms of k here. So on top, we can split that off as x to the 2k, x to the 2. Now, 2k plus 2 factorial is the same as 2k plus 2 times 2k plus 1 factorial, right? We can always step down. And 2k plus 1 factorial is the same as 2k plus 1 times 2k factorial. So you can always, for factorials, you just want to keep walking down the line until you get something that matches the other side. So on here we're going to have 2k factorial and x to the 2k. So we can see is that these 2k's are going to cancel, the 2k factorials are going to cancel, and x to the 2k's are also going to cancel. So now we have a limit as k goes to infinity of x squared over 2k plus 2, 2k plus 1. So here comes the tricky part. The tricky part is that in this limit, the x value is actually a constant. It's not a change, it's not a variable in the way you're thinking about it, because the limit is moving, the k's are moving, so the x is considered fixed. What does that mean? Well, that means that realistically I can actually factor out that x squared. And I can remove the absolute values because k is going towards positive infinity, and these are going to always be positive. So again, and x squared is always positive, or it's non-negative. So we now have that limit moving towards infinity. Well, as k gets large, that denominator gets impossibly large. So that tells me that this limit is 0. So now you have to ask yourself, okay, well, we set up over here, we said, okay, that limit has to be less than or equal to 1. So if it's less than or equal to 1, we're good. This one, the limit's just straight 0. So it's always going to be less than or equal to 1. It doesn't matter what I plugged in for x. No matter what I had plugged in for x, this limit was always going to 0. Because if I plug in a fixed x value, eventually the k values get so large it just drives it into the ground. So that tells me that the radius of convergence here is actually positive infinity. The radius is infinity. So it doesn't actually matter where my center is, because if I have an infinitely big circle, it will cover every possible value. And that's how we end up with that particular. And so if you have a radius of infinity, your interval will always be positive or negative infinity to positive infinity.